Hey guys, welcome to question MM363 of the Maths Methods Fortify study guide. So, in this question, Charlie loves to go horse riding. If he goes riding one week, the probability that he goes riding the next week is 0.9. And if he doesn't go riding one week, the probability that he doesn't go riding the next week is 0.2. Now, Charlie didn't go riding this week, and we need to find out the probability that he goes riding exactly once in the next 2 weeks. Awesome. So, as soon as we read these sort of questions, we need to recognize that we're dealing with conditional probability here, because something that he does in the past affects something that he does in the future. Okay, so the events aren't independent, they affect each other, which means that we need to always draw a tree diagram for these sort of questions. So we know that in this week, Charlie did not go horse riding. Okay, so he didn't go riding. Now we need to figure out the probability that he goes riding exactly once in the next 2 weeks. So he could go riding next week and then not the next, or not riding this week and then the next. All right, so we're looking for the probability that he goes once, which is the probability that he goes riding once and then not, or the probability that he doesn't go riding and then he doesn't go riding and then does go riding. Awesome. So if he didn't go riding this week, according to our piece of information that we're given in the question, he didn't go riding this week, so he has a 0.2 chance that he doesn't go next week. Okay, so he doesn't go riding, the probability that he doesn't go riding again is 0.2, which means the probability that he does go riding the next week is 0.8. Okay, so these two always have to add to 1. These have to add to 1, this has to add to 1, and these have to add to 1. Cool, so just following on this path, if he doesn't go riding the next week, again, the probability that he doesn't go riding next week is 0.2 again, right? So he hasn't gone riding this time, so the probability that he doesn't go again is 0.2, this bit here, which means that this is 0.8 again. Now, in this possibility, he has gone riding, all right? So if he does ride, he has a 0.9 chance to go again next week, right? So he's ridden, which means he has a 0.9 chance to ride the next week. So this is 0.9 here. Because this is 0.9 and these two have to add to 1, this is 0.1 here. Awesome. So now we can actually do all this. We can figure out our probabilities. So we're looking for the probability that he does go riding and then he doesn't. So from here, so he does go riding and then he doesn't. So from here to here. Now to figure out this probability, all we need to do is multiply our branch probabilities together. So this probability is going to be equal to 0.8 times 0.1. And that's it. Then we're looking for this one. So the probability that he doesn't go and then he does. So 0.2 times 0.8. Awesome. This is equal to 0.08 plus 0.16, which gives us 0.24, which is our answer C. Now, we need to be really careful about the syntax that's used in the question, because it says that he goes riding exactly once in the next 2 weeks, right? So if it said once or more, we could include this possibility as well, because he's ridden on both weeks, but we're looking for the probability that he rides exactly once, not twice. Okay, so we can only include once and then not then once. So that's it. So 0.24 is our answer for MM363. Guys, hit me up if you have any questions in the comments below, but otherwise thank you very much for watching, and I'll see you in the next video.